All right, we're going to continue with properties of exponents. And in the first video, I very quickly went over the actual properties themselves. You can actually just flat out do the math based on what we know for the first three, but there are some properties that make them a little faster. The last two here kind of rush through a little bit, but you can't really necessarily do them. You just have to understand or know that when you raise anything to the zero power, the whole thing becomes one. So raising something to the zero power is equal to one. And then when you have something raised to the negative power, first I want you to remember that everything is all over one. We don't have to show that all the time, but it matters this time, so I will. Because it's all over one, this negative exponent tells you to flip it. So the one goes to the top, and the 2 to the third goes to the bottom, but it is now positive. So we don't like negative exponents. The way we make them positive is by flipping them. All right, now that's all well and good, but let's do some examples to make sure we're solid on it, okay? Let's apply them. It's actually often easier to apply them than it is to really understand the straight up theory, but it kind of work together over time. So looking at this, I am multiplying two common bases. The property says that I should then add the exponents, right? So if I had a -2 as my common base and 3 times 3, or when I multiply this, I have 3 plus 3 or 6. If I were to write this out 3 times and write this out 3 times, I would have written it out 6 times. All right. For this one, I'm raising everything here to the third power. Remember, when you raise a power to a power, you multiply the exponents. I don't want you to forget that there is an exponent of 1 here, even though it's not written. So I'm raising this -3 to the 1 times 3 power. So -3 to the third power. Let me do the same thing for the x here. I'm raising the x squared to the third power. So I'm taking that base and I'm multiplying the exponents. And let's do the same thing to the y. I'm raising a power to a power, so I keep that base, and then I raise that to that power. Now, I'm okay with you simplifying that if you want to see that as -27, x to the 6, y to the 9th. I often won't require it, or I'll tell you if I need you to do that. If it's something real simple, I'm expecting you to do it. But if you leave it like that, it's generally okay. Generally okay. All right, let's go down to this one. In this example, I do have a number and I have some powers, but it's not the same as this example. Over here, I raised everything to the third power. Here, I'm just raising individual pieces to those powers. Now, what jumps out at me is this thing right here. There's a negative exponent. And since there's a negative exponent, that's going to imply that I'm going to have to flip something. So if I'm going to flip it, the moment I see a negative exponent, the very first thing I do is I draw a fraction bar, because something's going to be flipped and moved. First, is this thing right here going to go up or down? No, it doesn't move because my negative exponent doesn't exist here. So this -2 stays on top. Now this thing right here is a negative exponent. That tells me that goes to the bottom. Now it's positive. And then this b right here is not negative. It's not raised to a negative exponent. So that remains on top. So if I were you, I would try to do these things in pieces, right? Let me make that a little smaller. I'm usually not done, but I need to double check. I have b to the second. I can't combine that with any other b, so that's good. I have a to the second. I can't combine that with any other a, so I'm good. I have -2. Well, it's just -2. That's fine. Done. Let's look at this one. I see multiplication here. I see numbers. Remember, there is a 1 right here. So what I could do is, because of the other properties of multiplication, like grouping it and like associative sorry, mind just went blank. Either grouping it or rearranging it, the commutative or associative properties. Wow. I can just multiply the numbers together first. So 1 times 2 is 2. 2 times -3 is -6. So I can do the numbers first. Now let me look at all the m's. Oops, that's not an m. Well, in this first one, I have m to the first, m to the 0. M to the first times m to the 0, you multiply common bases, you add the exponents, that's really just m to the 1. And then if I look at the n's, I also have 3 and the 0. When I multiply common bases, I add the exponents, that'll give me 3. So really it's just -6 m n to the third. And we'll come back with the next one in a minute.